Hi everyone, I am Dr. Whitney Keaton. I'm a science teacher at George Washington University Online High School. And today we're going to be looking at a really neat demonstration, a really neat concept of polarity that you can probably do with items you already have around the house. So for my demonstration, I had a few assistants helping me out. These are my kids, and they're going to be showing you how you can do this at home.
Hi.
The materials that you need to be able to do this demonstration are pretty simple. You need a disposable plate. You could do this with a plate you want to wash later as well. At least one Q-tip. Some food coloring of assorted colors is best. Liquid soap, such as dishwashing soap. And you need milk. The higher fat content, the better. So whole milk or even like half and half or creamer would work for this as well. So let's see how this demonstration is done.
Okay, so we're starting with plates filled with whole milk, and we're going to put a couple drops of food coloring on each. About 2 drops of each color.
What's for having 3?
It's okay. 1 drop of each color if you're doing 3 different colors.
Mama, doing all red.
Do another drop. Okay, now put the cap back on.
I'm actually doing all red.
That 2 came out at the same time.
Oh.
Okay, are we ready?
Yeah.
Okay, take your Q-tip and dip it into the soap. Okay, now all at the same time on the count of 3, you're going to put it onto your drop of food coloring. 1, 2, 3.
Did I do it again?
Whoa.
Yeah, keep going.
Whoa! The green isn't showing up. Can I put more green in?
Yeah.
Okay, so now that you know what the procedure looks like, let's see this as a close-up because it was a little harder to see from the last view. All right, so what we have happening here is polarity at work. So first you need to understand what polarity is. Molecules sometimes have differing what are called electronegativities. And so in a polar molecule, you're going to have one end that is partially negatively charged and one end that is partially positively charged. And when that happens, they'll interact with other polar or non-polar molecules in very specific ways. So the rule of thumb is like dissolves like. So polar molecules will dissolve in other polar molecules. Non-polar molecules will dissolve in other non-polar molecules. A polar molecule and a non-polar molecule will repel each other. So you've seen this probably if you've ever tried to mix together oil and water. Those two things have different polarities. Water is polar, oil is non-polar, and therefore they repel each other and they will not mix. So here with our soap and our milk, and the milk contains fat. Remember, I told you that you should use the highest content fat milk that you can get your hands on because it's going to work better. Because that is what is being repelled by the soap molecule. So soap molecules are interesting because they have a hydrophilic end and a hydrophobic end. The hydrophilic end is polar And basically what it does is it repels those fat molecules. This is how soap cleans things. It is going to repel, it basically surrounds the fat molecules and repels them, and then that's how you can rinse it off your hands or the dishes or whatever it is that you're washing. All right, so let's see it close up one more time. So you can see here that the soap on the Q-tip is clearly repelling those fat molecules, and the fact that we put food coloring in the water allows us to see this happening because you can actually see the milk molecules moving away from the soap.
Thanks for watching.